All right, welcome back, ladies and gentlemen. This is the next installation of our Astronomy Unanswered Questions with your host, Mr. Mikulski. Today, we are in session number 6 of this series, and I have a set of questions coming to me from the letter S. And the letter S says, what is the chance of alien life existing in our universe or galaxy? All right. Well, I think this is a great question. I think that those are kind of two different questions in the sense of like the universe versus the galaxy. So there is something. Let me give you the quick answer first. To me, as an opinion, 100% chance that alien life exists. Done. Okay. Now, the more in-depth answer to that is within our galaxy, right, the Milky Way, versus the entire universe, the billions, hundreds of billions of galaxies. Okay. Um, so there is something called the Drake equation. I'd recommend you looking it up. It's a little bit complicated, but it kind of goes into the idea of if we look at a statistical probability, in other words, what are the chances that life would exist? It evaluates certain things. What are the conditions that we need for life? How often are those conditions met? And how like many different places or ways could that have happened? So that way, over enough given enough time, that life could exist. And I think the Drake equation may even go so far as to say not just any kind of life, because technically, if you're saying alien life, that's a piece of bacteria growing on some random Martian rock that we could say is different, perhaps, from Earth-like bacteria or Earth-like life. Then there's alien life done. Okay. Now, if you want to go into intelligent life, then you get to a few extra components to that. And in the end, the Drake equation does give a roundabout number based on your inputs. And so you can kind of tweak it a little bit with that. But I would say chances of life existing is pretty high, simply because there are so many planets and stars and within our own galaxy, let alone within all of the different galaxies within our universe, that I would find it very hard to accept or believe that we are truly alone. That would be a scary thought. All right, good question. All right, what will happen at the end of the universe? Okay, so I've addressed this a few times already, but obviously it's a popular question. We don't know, but there are a couple ideas, and so I'm going to refer you back to a previous video. But quick answer is something called heat death, which basically means that the universe will continue to expand forever, and eventually everything within it will get cold and far apart from everything else. And so it's basically going to die from lack of heat, right? The death of all the heat in the universe, it will basically become zero, okay, temperature-wise, thermal energy. Other ideas are something that we have a big crunch, so the universe will expand to a point, and then eventually it'll be like a rubber band. It'll start to come back in on itself and then kind of collide, if you will, sort of like the beginnings of a new Big Bang. And then there's other models that would suggest, oh, we're just going to keep expanding at a certain constant rate, or we're going to expand at an accelerated rate, or even that maybe like there's a point that will expand and then maybe we'll stop expanding. Maybe the universe will just stay static in terms of its volume, its size, and then it'll just kind of coast, if you will, for the rest of eternity, whatever that may be. But yeah, those are some of the more basic thoughts as to what might happen at the end of the universe. All right. How long would you survive in space without a spacesuit? This is a great question because I think this is something that a lot of people have misconceptions about. And again, I'm not going to pretend like I'm the expert, so I don't remember the details exactly of the situation. But what I would tell you is that it's a matter of minutes, as opposed to some people might think like instant death or within seconds. No, it does take a little bit of time, but the scary part about it is all the ways that you will die. And I say that it's not all the ways you could die. It's kind of like they're all going to happen pretty much simultaneously. And that's kind of exciting or scary, terrifying, like a good horror movie. But the one, here's my recollection of the answer to this. Um, if you take off your spacesuit and you're out there in space, if you are facing the sun, you will instantly, or maybe not instantly, but again, very quickly, within a matter of seconds or minutes, you will be burned in the sense of like imagine the worst sunburn, right? Simply because there is no protection from that ultraviolet radiation that is getting to you. If you think about it, we're here on Earth and we can go outside for a while, a couple hours, whatever, and depending on kind of your skin tone and things like that, you might not get a sunburn at all. You might get a tan or something like that after a little bit of time. If you're out for too long, okay, then you start getting burned and things like that. But and again, sunburn. But that's after that sunlight has been filtered through all of the atmosphere and the ozone layer, which is actually a high. It's responsible for protecting us from some of the UV rays of the sun. Okay, so from that standpoint, you are outside of that envelope, if you will, of safety by being out in space, even just in low Earth orbit, and so you're going to get burnt quick. Okay, so that's going to happen on the surface. Other things that will happen when you are not in your spacesuit, the fluids in your body will begin to boil. Now, it's not actually as bad as it sounds. And the fluids, not necessarily fluids in your body, it's not like your blood, but like the saliva in your mouth or any mucous membranes on like your eyes or in your nose, things like that. Any liquids that are like exposed to the outside, that are not contained inside of a blood vessel or inside your organs and things like that. And the reason for that is because there's the lack of pressure outside allows that liquid, right, primarily water based, if you're talking like salivas and things like that, to boil, and they boil at low temperature. So again, it's not going to get hot, but it will literally bubble off as that liquid will turn into a gas and it will escape from you in space. So I think that would be a really weird sensation to have either the bubbling in your mouth or even like on your eyeballs because there is like a layer of liquid in your eyes. And so that would be kind of just crazy, even though that's not really a painful thing. It's just a weird thing. Then, other than that, then we start dealing with the cold, right? So, space in general, like outer space, if you will, outside of Earth, it's about 2.3, 2.7 ish. Let's call it rounded to 3 Kelvin. 3 Kelvin is three like ticks above absolute zero. And so if you think about 0 Kelvin is like negative 273 degrees Celsius, I believe it is. So you're talking like about negative 270 degrees Celsius. And don't ask for what that is in Fahrenheit. I have no idea. But you can do the math. So it's cold. Now, the thing is, you don't like turn to a popsicle instantly because it takes time for the heat to leave your body. And in space, it's a very slow and inefficient process for that heat to leave. So you will start to get cold, but it actually it won't be as fast as you might think. It will actually take a little bit of time because it's very inefficient for the heat to essentially to radiate away from your body and go out into space. Okay, so you've got the sun, you've got the cold, you've got boiling liquids. What else? Oh, yeah, by the way, you're going to pass out because you have no oxygen to breathe. So that'll probably happen pretty early on, too. So you don't really have to worry about too many of the other issues because you'll probably be unconscious pretty much before a lot of the other painful things start to happen, like the freezing and the burning part. That might happen around the same time, the burning, anyways. But yeah, those would be some of the things that you might experience. So you're my long answer, adding it to making it short again. How long? I believe the approximate value is a number of minutes. It's kind of like how long could you hold your breath for before you die, and then beyond that, you start getting brain damage and then other exposure issues. But yeah, it's definitely minutes before you have to really worry about severe damage. All right. Hope you enjoyed that one. That was nice and long. All right. Well, let's stop there. Thank you to S for sharing those questions with us today. I'm going to go ahead and move on to another user questions, and we'll see if we can get through these, and then we'll stop this video and make another one. All right. So this is from SE, not to be confused with the previous viewer S. And SE writes, Will we ever get the technology to find out what's in a black hole? Wow, that's actually a really great question. Um, my personal opinion is that for everything that we understand about science today, science including physics and astronomy and cosmology and all the things that relate to black holes, relativity, um, I think no. I think there's going to always be that like that shroud that covers that kind of the mystery beyond the event horizon of the black hole, and all of our current learning and understanding about them suggests that's how it will be, how it should be. Um, but I say that acknowledging that that's based on our current understanding of things. It's based on our current technology and abilities. And so, who knows what abilities and what knowledge we as a civilization, as a human race, will have in 100 years? Or wow, think how far could people get in 1,000 years from now? Like there's crazy advancements to be had that I don't think there is necessarily an upper limit. So, from that standpoint, I think we could get there, but um, it's just like it's too hard for me as an individual to see that. So I don't know. I mean, nobody knows the answer to this, I think, but will we ever get the technology to find out? I hope so, but I'm afraid I don't think that we will. That's my thought. I don't think that we will. That was like sad. I don't know. Okay. All right. SC says, next question. How do we get a clear picture of a black hole? Ooh, so there are these pictures of black holes. And in fact, here, if you can see this, there's one of them. Okay. So that's on my cell phone. It's my like screensaver. Don't tell my wife and kids. Actually, they know about it. But anyways, so that is one of the very first photographs of a black hole. And believe it or not, that only happened within the last, I think it's like 2 years or something. It was relatively recent. And so that just goes to show that like we are still making progress. We're still just like the babies. We're just learning. We've only learned how to take a picture of one now. Now, granted, we've had a lot of other stuff that we've been able to do before we could take a picture. So it's ironic that like seeing the black hole is kind of coming after the fact that we already can describe a lot of the properties and the situation and the behaviors of them. And so that is kind of a strange circumstance that we're under. But the picture comes from, if I remember correctly, that LIGO, that Laser Interferometer Gravitational Observatory, if I say that correctly, is the thing that's detecting gravity waves. And I don't know if this is actually what was used to discover where the black hole was, because there are two black holes that we took pictures of. One was like the black hole in the center of, I think, another galaxy, if I remember correctly, and then another one was maybe a black hole, like a planet or a stellar black hole that was maybe in our own galaxy. I could be totally wrong on those two things. I wish I remembered. But the point is that we can notice where we think a black hole would be because of the effect a black hole would have on its surroundings. In a way that, like, if you were to look at a bathtub, and let's say that bathtub was filled with black water, okay, just for the heck of it, and you saw a swirl on the surface of that black water, you could probably deduce that somewhere underneath that swirl is the drain, even though you can't actually see the drain itself. And so, in the same way, the swirl of matter, stars, gas, dust, clouds, things like that, that we see in space, that might be what we are seeing. We are seeing those things because those are the surface features, and yet the black hole is like that drain that is causing the swirl in the first place. And so while you can't see the drain directly, you know where to look because you can see the effects of the drain. And so that could be one way that we've done that. The other part too is like, well, we know that there's a black hole at the center of our galaxy. I mean, there's a supermassive black hole. So that's been pretty well understood or established for a while. The how to take the picture of it, that becomes the issue. Is how do we get an image that doesn't get obscured by all the stuff that is between us and that black hole? And there are, I think, like three really great Veritasium videos on this. where he talks about what it looks like, why it looks the way it does, because it's got a really funny look to it. And again, he does go into, I believe, the process of how to take a picture and how to kind of eliminate the noise. If you're anything into photography, you might recognize that like in a photo, there's kind of that like that negative space and that the positive space or white space or dark space or whatever they call that in art. But the idea being that there's the thing you want to focus on in your picture, in your art, whatever, and then there's the everything else. So the same is kind of true in astronomy, right? If you take a picture of the sky, well, I don't want to see all of this, that, and the other thing. I want to focus on just the one object that I'm interested in right now. And so, from that standpoint, there are filters and there are ways to digitally, either enhance or just like kind of in a sense crop out the parts that you're not interested in and focus on the ones that you are. And again, there's much better technologies out there that they can choose which wavelengths of light to receive. So whether if we're looking at it in an ultraviolet light or infrared or gamma rays or x-rays or visible light, there's all different ways that we can see these different things in our universe. Okay, I guess I'm getting chatty today. Okay, but user SE is going to ask one more question, so let's do that and then we'll stop this video and start up a new one. Will it be possible to get a quick picture inside the sun? I think that's what they're saying. Um, I I'm not sure what you mean by this, but if you're just talking about like getting any kind of picture inside the sun, then no. And the same way, we don't have any pictures of like what the Earth looks like on the inside. We can think of what it might look like. We can evaluate the density and what we think the materials are made of for each layer as we get closer to the core. But we don't actually like nobody's been there. Nobody's actually like seen it. And there is no, in my knowledge, a way to take a visual photo of that. And so the same is true for the sun. We can analyze it and kind of evaluate the layers of the sun and how it behaves, and with different models and things that we simulate. There's actually a really cool group of scientists that I think they're working on. I forget if they're trying to recreate the solar magnetic fields or Earth-like magnetic fields, but they took a huge ball of like sodium and something else, and heated it up really hot and then started spinning it. And they tried to evaluate what kind of magnetic field was generated by this. And so the point is, this is a little bit less to do with your question, but what it does have to do with is that we can try to simulate on a smaller scale things that would behave or create magnetic fields or different behaviors that we experience here on Earth or that we experience from the sun. And then from that, we can figure out what the composition of either of those two items are. And so from that standpoint, again, no photographs, but we can definitely learn more about them. All right, we're going to stop there. I think this video has probably got long enough. Thank you if you're still with me. I'm going to start saying like and subscribe. Add a comment. What's your questions? Any other questions I didn't get to? Throw them in the comment section, and I will do my best to get back to you. All right, I'll see you in the next video.